In today's Python statistics video, we're going to be taking a look at the paired sign test. We're going to go through a manual example, and then I'm going to show you how we can implement this in Python with the help of SciPy. But before we jump into the coding side of things, let's go over a little bit more information about the sign test and when we would want to use it. All right, so some more info on the sign test. You can use the sign test for single sample or matched pairs. This video is going to focus on matched pairs. If you're looking for single sample, though, don't worry. I have another video on my channel, or it'll be out pretty soon because I'm recording these back to back. Essentially what it is, it's a non-parametric statistical test used to determine if there's a significant difference between paired observations. And if your paired observations, if the differences are normally distributed, often you'll use the paired t-test. But if it is not normally distributed, you want to use something that's like a non-parametric test, kind of like the sign test. So what we want on these pairs is they need to be related, but the differences between the different pairs, they need to be independent, right? And since this is a non-parametric test, the specific distribution does not matter. Okay. So now let's talk about our null and alternative hypothesis. So the null hypothesis is the median of the differences between the paired observations is 0. The alternative hypothesis, the median of the differences is not 0. There has to be some sort of difference. So the steps that you want to take, there's 7 steps in general. So I always want to start off with finding like the null and alternative hypothesis, your alpha values, stuff like that. Technically it doesn't need to be in your steps, but we do this anyways when we do some sort of hypothesis testing. Then what we want to do is we want to calculate differences between each pair of observations. It doesn't matter if you do before and after or after minus before. Just make sure you're consistent across the board, right? Next is if you're going to go with the sign test specifically, you want to look at using Shapiro-Wilk. You want to use a sign test when it's not normally distributed. So Shapiro-Wilk is a super easy way to check. Again, pass in your differences data into Shapiro-Wilk, and you'll get a p-value. If your p-value is less than 0.05, it is not normally distributed. All right, you want to also ignore any pairs where the difference is going to be exactly 0. It doesn't give us the direction, whether it's a positive or a negative sign. And then we want to count the number of positive differences as well as the number of negative differences. We take the minimum between the positive and negative differences. That becomes our test statistic. And then we want to look at the binomial test and get our p-value. So I'm going to use an example from running. Sorry, I love running, so that's what a lot of the videos are focused around. We'll look at 800 meter times and what before and after based off of a new shoe that's being introduced to a running club, right? So we have our before times, we have our after times, we have the alpha value of 0.5. The assumption is the difference is not normally distributed. Again, I'll show you Shapiro-Wilk when we get into the code, but for here, whatever, right? We have also our null and alternative hypothesis. The null hypothesis, the new shoes make no difference. The alternative hypothesis, the new shoes make a difference in 800 meter times. So what I have over here, first column is going to be our before, second column is after, and then we have our differences across the board, right? So you can see 120, 130, 135, 118, 125, and you see positive is 6, right? 1, 2, 3, 4, 5, and 6. Negative is 4, 1, 2, 3, and 4. Okay, then what we want to do is find the minimum. Well, we have 6 positive, 4 negative. So we're going to go with 4. And then also we have 10 for n. There's none that are 0. So we count this positive plus negative, which is 10. And we say the probability is 0.5. And then once we run the binomial test, we get a p-value of 0.753. Which is much greater than 0.05. So we fail to reject the null hypothesis. The result of the sign test shows that there is no significant difference with impact of the new running shoe at the 0.05 significance level. So that is just a quick walkthrough. We'll jump into some Python code, showing you again how to do this through a few different steps, shortcuts, and at the very end, it'll take like 1 line to solve this. So get your notebook ready and let's start coding. All right, let's get started. So we'll say from scipy.stats import binomial test and Shapiro, and then we'll import in port numpy as np. This will get us through the first few examples. I will also show you guys a shortcut here at the very end. We'll also set our alpha value 0.05. Okay. And we're off to the races. So let's replicate that example that we covered here in the slides. So what I'm going to do is define our data. So we're going to have our befores, right? And these are the values 120, 130, 135, 140, 135, 150, 140, 130, 145, and 138. Okay. And then I'm also going to paste in our afters, 118, 125, 130, 135, 133, 52, 37, 32, 46, and 139. Now what we're going to do is calculate our differences. For this test, it does not matter if you do after minus before, before minus after, since we're just taking a look at signs, right? So choose whatever way you want. I'm just going to do before minus after. So differences equals before minus after. Okay. And just to show you what these also look like, I'll print out our differences over here. All right, so you can see 2, 5, 5, 5, 5, 2, -2, 3, -2, -1, -1, right? Okay, so now what we need to do is find our positive and negative differences. So this is pretty easy. You can just say positive diffs equals, and we'll do np.sum, and we'll look where differences is greater than 0. Remember, we're removing any zeros. There's no zeros in here, so we don't have to really care about it, but that's why we have it like that. And then less than 0 for negative. So just change it to negative. Run both of these over here. Nothing too special, right? And what we'll do next is we'll calculate our test statistic. So to calculate our test statistic, remember it is the minimum. So we'll say test statistic equals, and then over here you just do minimum, pass in positive, pass in negative, positive. Then you have your negative over here. Now that you have both of those, print out our test statistic. So print test statistic, and then you can see it is 4, right? There's 10 total samples, 6, or what was it? 6 positives, if I remember correctly, and then 4 negatives. Yeah. So that's why we went with 4. Now what we need to do is find our n value. We could define it as 10, but really what I'm going to just do over here is say n equals positive plus negative. The reason why is just in case you have any zeros, right? That's why you don't want to define it as 10, but this will give us our true accurate n number. And then if we want to get our p-value, we'll have to do a binomial test. So we'll say results equals binomial test. Then first pass in your test statistic. So we have that here. Then we're going to want to pass in our n value. Then we're going to have to pass in p equals 0.5. Right, 50%, positive or negative. And then we'll say alternative equals, and we're doing a two-sided test, so make sure it's two-sided. Okay, and now to get your p-value, we'll say p-value equals results dot p-value. Right, and we should get 0.75, so print out our p-value over here, and 0.7539. So we're looking pretty nice here. So really, this is kind of one of our shortcuts. So before, after, right? Find differences, then find number positive, find negative, add those up together, find our n value, right? And then just pass it into a binomial test. Our test statistic and our p-value of 0.5 over here for probability. And then we get our actual p-value. Okay, and now what I like to do in these videos also is just have an if-else statement. Just doesn't have to be anything too crazy. Again, this is just a practice video for you guys. So p-value less than alpha, the median of the differences is not 0. There's a difference, right? Else the median of the differences between the paired observations is 0, no difference. And is 0, no difference, right? If our value was less than 0.05, there'd be a difference, but there really wasn't much in this case. Okay, all right, so now what we're gonna do is we're gonna take a look at example 2. In example 2, we're gonna have a lot of differences. So first off, we're only gonna look at one tail, right? Then we're also gonna have 0 values. We're also gonna run Shapiro. And as a bonus over here, we're gonna look at ordinal data. So ordinal data, quite different than our first example. So let's jump right into it. I'm going to just copy over the values. So before 3, 4, 2, 4, 3, 4, 5, 3, 4, 2. Imagine these are mapped to different test scores, right? A, B, C, D, F. I just did the extra step already rather than converting them. So there's that. And then we'll have our after over here, right? 2, 4, 3, 5, 3, 5, 5, 4, 5, and 3. Okay, and the first thing that we're going to do is going to find our differences. So we'll say differences equals before minus after. Again, does not matter. After, before, after, same thing, signs, right? And just to show you, we can print out our differences over here. And you can see 1, 0, negative 1, negative 1, 0, negative 1, 0, negative 1, negative 1, right? So a decent amount over here of zeros. So I think we have 3 zeros in general. So now what we want to do, since we have our differences, is to calculate the Shapiro p-value, right? So we'll say Shapiro stat, Shapiro p-value equals, and then just do Shapiro, pass in our differences, and it should not be minus, it should be equal. There we go. And what we're going to do now is just print out this Shapiro p-value. Ideally, we want to have it under 0.05, and you can see it's 0.002. So to reject the null hypothesis, and this is not normally distributed, right? In a professional setting, you want to probably have an if-else statement and tidy this up. This is a YouTube video, so let's keep moving forward. Okay. Now what we want to do is we're going to find our positive and negative diffs. So we'll say positive diffs equals np.sum. This is the same thing we did earlier, right? Differences 0, and then literally just copy the same exact code, make this negative, flip the sign over here, boom, done. Positive and also our negative. And now we need to go get our test statistic. So we'll say test statistic equals, we'll have the min between positive and negative. So positive over here, and we have our negative, right? And print this out. So print out our test statistic. Should get 1. We do. And you can see there's only 1 positive, so that's why we get 1, again, the minimum. Now we need to get our n value. Now, it's not going to be 10 because we have 3 zeros, so it's going to be 7. But we'll say n equals, and we'll add these together over here, right? So just add those like that. And then we'll print out our n value. Print n, just to show you if you don't believe me, we're up to 7. Okay, and now let's get our results. So we'll say results equals Binomial Test. And first thing we're going to do is pass in our test statistic, right? So we have that. We'll say n equals n, p equals 0.5. And then for alternative, we'll see it equal to less, right? And then what we can do is grab our p-value. So we'll say p-value equals results.p-value, right? And then we can print out our p-value. So print out our p-value over here. And you can see it is 0.0625, very close to rejecting it. All right, and then I just pasted in our if-else statement right here, if p-value alpha. I made one slight modification. I say there is a difference, which is less, just because I went with the alternative less based off of the one tail. But you can see the value over here, 0.0625. Got pretty close, but since our alpha value is 0.05, we just don't have enough evidence to reject it. So what we say is the median of the differences between the paired observation is 0, no differences. Now, what I wanted to show you also is there is a shortcut, and it's through statsmodels. I haven't used statsmodels, I believe, yet in this series. So just to show you that there is a shortcut, we'll say import statsmodels, and then we'll have is from statsmodels.stats.descriptive stats, import in our sign test. So sign test like that. And what we have to do, I'm just going to go through our first example again, right, with our before and after. So not this one. Where's So we'll copy this one over. So we'll have that before, go to the top again and grab our after. Do both of those. Awesome. So just running our first example through here again. This is the third time we're doing this, but we'll say sign test. And inside over here, just pass in before and pass in after. And you can see 1. We don't care about that. We care about this our p-value, which is 0.7539, which is what we got when we did the binomial test, right? It's 0.7539, and we did all those extra steps. So you can technically do this in literally like one line of code with the sign test from statsmodels. Or if you want to go the SciPy route, right, use binomial tests and do what we just did. But yeah, that's essentially it for the sign test that is paired. Not too bad on the coding side of things, although I do wish SciPy had the sign tests kind of like what statsmodels does. But regardless, now you should know how to do it. Hope you guys enjoyed this video on the paired sign test, and if you found some value in it, make sure to subscribe to the channel. It's 100% free, and we're trying to upload at least 3 to 4 different data science videos every single week. Now, if you want to continue learning about statistics with the help of Python, I have a few videos linked down below in the description and a playlist right over here.